Hello friends, welcome back. I am Rajnesh and this session is about Linux boot process. Have you ever wondered how the boot process or a boot sequence of a Linux goes on for a laptop or a system? So as soon as you press the switch on button, the first thing that happens is the BIOS is loaded. BIOS is basic input output system and it is present on a read-only memory ROM which is present on a chipset if you look into the motherboard. So the first role of the BIOS is to perform POST, which is power on self test. So as soon as the BIOS is loaded, the first thing that it does is make sure that the hardware attached to the system is working fine. The hard disk should be working fine. The keyboard and screen should be accessible. So these are the generic system devices that it loads, and you can work on those and make use of that, because screen shows you display, because BIOS provides this functionality of loading this screen drivers into it. The same happens with keyboard. You can work with keyboard because BIOS or basic input output system allows interaction with the generic hardware. Okay, so BIOS can be configured to boot from any of the device, or you can specify a sequence from which it is going to boot. BIOS could allow you to boot from hard disk, it could allow you to boot from optical drive, it could allow you to boot from USB, from network, and so on. So if you have ever gone into BIOS, it can be accessible just by pressing a del key as soon as the system boots up, and it shows you at the bottom that press del to enter setup. That is what is the BIOS setup. There you can configure your first boot, second boot, third boot devices. You can specify the password. You can specify some advanced parameters related to your processor, CPU overclocking, and so on. So in general, we'll talk about the boot process. So in case the first boot device is hard disk or CD-ROM, what actually it does is it hands over the control to the first sector of the disk, whether it's CD, DVD, or hard disk. So the first sector of the hard disk has the information how to start booting from it. So the first sector consists of master boot record, which is also known as MBR. So here it is. MBR knows how to boot from that particular hard disk. In case you have a multi-boot environment, you could be having Grub or Lilo installed on it. Lilo is Linux loader and Grub is Grand Unified Bootloader. Both of these provide multi-boot environment. So in case that is installed on the MBR, Grub is the first thing which is loaded. And after the Grub is loaded, you will see that it provides you a menu. I'll show you. I have switched on. It is the first boot device is IPXC. It is trying to boot from it but unable to boot. So here you can see this menu corresponding to Grub. This is the Grand Unified Bootloader, which is loaded on the master boot record, which displays you a list of operating systems present on it. So if you see right now, you can see only one option, which is CentOS 2.6. It doesn't display you multiple operating systems. It could be multiple operating systems. In that case, the menu is fetched from boot grub menu.list. I'll show you as soon as the system boots up. So if we see to the section corresponding to it, just press E, and here we can see the first line is root hd 0,0, which says, okay, HD0 means the first hard disk, Comma 0 means first partition. So HD1 is second hard disk, HD2 is third, and so on. The same happens with the partition inside the hard disk. Comma 0 is first partition in that disk, comma 1 is second partition in that disk, and so on. So first line root HD0, 0 says your kernel and init are present in the first hard disk and first partition. Coming on to the second line, which says kernel slash VM line use. If you monitor it carefully, it's slash VM line use instead of slash boot slash VM line use. Why? Because HD0, 0 or the first device first partition is actually the boot partition. And the same is the reason why init is slash initramfs instead of slash boot slash initramfs. So first line says where actually your boot partition resides, or on which partition you have kernel and init images. Kernel line can be used to specify multiple options to it. It can be used to specify whether SC Linux is to be enabled, whether it's to be booted into single user mode, or it's to be booted into a particular run level, and most importantly is the root file system location. If I just press E, I'll show you. Here are the parameters. Key table type, keyboard type has been specified, no distributed mapping multipathing, and the most important part is here. First you see read only. It means initially the kernel is loaded in read only mode, and root equal to dev mapper and the path of the actual root device. Escape, come out of it. Init. Okay, the kernel has been statically compiled with various drivers, but these drivers are not sufficient to load the operating system, or they may not be capable of loading the root partition. Let's consider the scenario when we have the actual root partition on LVM or RAID. So you may be needing init. Init is the initial RAM disk, which consists of the device drivers which are necessary to load the actual root file system. It's not possible to load every module into the kernel because that makes the kernel size very large. So kernel has been statically compiled with the drivers which are necessary to load init and to load the generic devices for keyboard, screen, and so on. So additional device drivers specifically required for a particular system. It could be Ethernet device, your SCSI drivers, it could be LVM, RAID. They are all present in init. So okay, we press escape, and as soon as we press enter, it's actually doing in the backend marking root as HD0, 0, loading kernel, and then loading init. Dracut is actually this initramfs infrastructure. Here you can see that it has loaded SCSI devices, ATA devices, your hard disk has been loaded. So SCSI, it provides you the details of SCSI, CD-ROM, and VirtIO. SR0 is your CD drive, and here it has detected the first device, which is SDA, SDA1 and SDA2. So now it will try to fetch out the details from the devices. Here you can see that it has found that it has two LVMs, logical volume corresponding to root, logical volume corresponding to swap. They are presently in inactive state, so it will try to activate this root. Here you can see, okay, the devices have been detected and logical volumes have been found. Now it sees whether the root file system requires any kind of file system check, and now it mounts the root file system in read only mode, and after that it has mounted the root file system. It switches the root to the actual root file system but in read only mode. It's starting UDEV, checking out for the devices. Here you can see that it has started loading the devices corresponding to the SCSI devices, and here it loads Ethernet devices. Setting up the host name. How the setting of the host name works is it has fetched out the details in /etc/rc.sysinit, and I'll show you later in the file. It sets the host name, checkouts for the inconsistency in the file system, and finally loads the file system. Checks out for the logical volumes, make them active, and mount them as required. So here it checks the file system. The FSCK was run, they were found fine, so it's remounting the file system in read write mode now, and it checks out in etcfs tab for the presence of various partition and mounts them up. Enabling etcfs tab, swaps were enabled and it starts monitoring them. And now if you see, what it actually is doing is it's starting the services that are present in the run level corresponding to the run level we are booting into. The run level which the operating system has to boot into is present in /etc/init tab. I will show you as soon as it boots up. The first process that was initiated after the kernel was mounted was sbin init. It checked out the configuration from etc/rc.sysinit and mounted the partitions. Run level was present in etc init tab. I'll show you, let it boot. So if you see to the sequence, you will find I'll show you root, and I just enter the password. Okay, so the first thing that we were talking about is the Grub, which is the bootloader which is present on master boot record, which is responsible for loading multiple operating system. So how is that menu generated? Boot grub menu.list. This is the file. Here you can see the default operating system which it should boot into. By default it is 0, means the first operating system. First one starts with title. You can have a different title which loads a different operating system. Splash image is the splash screen that you can see corresponding to that you can see in the Grub. Timeout. In case you don't press anything, for how many seconds should it wait? Hidden menu means the menu is not visible by default. If you just comment it, the menu will always be visible. Title: this is the text which is actually available or visible to you. This is the root hd0,0 which I displayed you when it started booting. This is actually the boot partition. I'll show you. Kernel, the location of the kernel. Here you can see slash vmlinux initRD slash initramfs, okay, ll slash boot, and you can see that initramfs is present inside boot, your vmlinux is present inside boot, and if I just press llroot, here you cannot see initramfs or vmlinux. Why? Because they are present at boot partition. If I see df-h, we can see hd0,0 is sda1, which is the first device, first partition. First SCSI device is SDA and first partition is 1. So SDA1 is actually the boot partition. So it means, okay, it means mount the first partition of the first disk, which is boot partition, and here you can see vmlinux inside it. The same happens for initRD. As soon as it's able to find this kernel and initramfs, it loads them into the memory and starts booting. So when we come to the first process, okay, ps-ef grep init. Init is the first process with the PID of 0. It's the mother of all processes. So this is the first process that is initiated. Run level. We can see that it has booted into run level 3. So which all programs should be running when it boots into run level 3? /etc rc3.d. We have certain folders corresponding to rc star.d, rc1.d, rc2.d, rc3.d. so they consist of the set of scripts to be stopped or started when a system boots into a particular run level. We are talking about rc3.d. Here we can see a lot of scripts which are actually linked to the files present in /etc init.d. Here you have the actual scripts. So here we have symlinks in rc3.d, which says as soon as you move to run level 3, the scripts starting with capital K should be stopped. For example, IPA should be stopped. creg, these services starting with K should be stopped, and starting with S should be started. And the sequence goes from S01 first, S02 the second, and the same numeric order works for S and the same for K. So this specifies the sequence in which the scripts should be started. Okay, one more question. Which is the default run level which the system should boot into? The file is /etc init tab. Here you can see the init default 3. So the default run level is 3. We have multiple default run levels. It could be 0, which simply means halt, which should never be there as default. 1 is for single user mode, the least number of services running in it. 2 is multi-user without NFS. Here you can see. 3 is full multi-user mode but without GUI, genome or KDE. Run level 5 is with GUI, and 6 is reboot. So run level 6 should never be set to the default. Run level 0 should never be set to default. And the first file or the first script that ran was rc.sysinit. Sorry, rc.sysinit. Here you can see it checks out the details, setting up the host name, mounting the file systems, and running fsck if required. You can go through the complete file. Okay, so finally we are left with one more thing. What if we want to run some custom script or custom commands as soon as the system boots up? There is a file /etcrc.local. Here you can type the name of my custom script, script.sh or whatever it is. So here you can specify a list of scripts that you need to run as soon as the system is booted. This is the last script that runs after your system is completely up into a particular run level. What in case if you want to run the script at a particular location? For that we'll have to do two things. First of all, we create a script inside the folder etc init.d. For example, I touch it and I can create the script which says I'm not going to write the script now because that requires a separate session. Actually, this script should be able to respond on start, stop, and it doesn't work because it's not an executable, it has nothing in it. So it should be configured so that it works with an argument start, stop, and restart. First thing. Second thing that we do is chkconfig --add test error reading information on service test, cannot allocate memory. Okay, we will do it in a separate session because it requires some more time. As of now, let's recall the things. First is we switch on the system. Switching off the system hands over the control to basic input output system BIOS, which loads the generic devices, performs power on self test to make sure that all the devices are working fine, and hands over the control to the master boot record of the hard disk or the CD drive from which it has to boot. The MBR consists of the bootloader, it could be Grub or Lilo, which has a menu which specifies where to boot from. In the menu.list, these files are specified, which should be the root device, where should be the kernel and initrd. Kernel consists of static modules compiled into it. Initrd is required because we may be requiring some additional modules that are required for booting up the operating system. It could be the support for LVMs, SCSI drivers, and so on. And after that, initrd has been loaded. It can see all the devices. It loads the root file system, and after the root file system is actually loaded, the first program that is initiated is sbin-init, that checks out for the configuration in /etcrc.sysinit and then runs the fsck if required, and after that it checks out for the run level in /etcinit tab and boots into it and runs all the scripts present in rcn.d, and the final script that are run are present in etcrc.local. So that's all for the boot process. I'll be creating a separate video for what happens if the MBR is corrupted and the system reaches to an unbootable state. Thanks for listening. Have a good day.